Our sermon today is Global Warming and the Nature of Science by our guest speaker, Victor Marshall.
Good morning. When I was first scheduled to give this talk, we had the most severe and prolonged windstorm that Michigan had ever had, and the greatest electrical outage in Michigan's history. Comes from global warming. My original title was Global Warming and the Nature of Science, but since science has been so maligned in the last, few months, I decided to switch it around and talk a little bit more about the nature of science. I think that our society, especially a lot of politicians, and I don't want to get political here, but a lot of politicians really don't understand science and how it works. So, with that in mind, the whole reason for this came out of our covenant that we have. Number 7, respect for the interdependent web of all existence of which we are a part. This is something we've talked about. This is why we got our lights changed. Now we're using 1/6 of the electricity that we formerly used to light our church and our sanctuary and social areas. Actually, all of the areas. We've got a bunch of new light bulbs in here. Also, Reverend Cindy is going to be dealing with energy stewardship later on in the year. So this is kind of to give you a little bit of an idea on why we need to be involved with that energy stewardship. Science, it looks like a lot of stuff, but it's actually pretty simple. We make observations, we try to figure out why, we formulate a hypothesis. Now, to a scientist, a hypothesis is a working idea of what I think I'm going to find. Don't know, but that's what I think is going to happen or what the cause is going to be or whatever. We develop some testable predictions. We gather data to test those predictions, and after we've gathered some data, we might have to go back and refine, alter, expand, or say, this just isn't working. Got to try something different. Ultimately, we develop a theory, and then we continue to make observations, continue to collect data, and continue to either substantiate that idea or say, doesn't work. Or actually, what scientists are really fond of saying is, we need to do further research on this. And we keep collecting more and more data. And we go off into these tangents and so on. We're really just trying to make sense out of the earth. Why is it the way it is? So we collect data, we make our observations, we try to work with them. The key thing is we try to use those to make predictions. If I heat this metal to this temperature and then I can bend it and it stays strong. If I give this drug, we can cure this disease, and so on. If we do this surgery, we can help make somebody better. And those who've spent their lifetime studying these data and events are the ones that society has agreed to give credence to. I was a molecular biologist. That was my professional training. So I would expect people to have credence to things that I talk about on molecular biology. Astrophysics, not so much. There's a whole bunch of areas where it'd be not so much. Now, I started out as a chemistry major and a physics minor, so I kind of know some of that stuff, but not in depth and not as much as it's changed during my professional career. We also give credibility to those who publish their work. Now, publishing to science and scientists is not putting it in the National Enquirer. If I'm a molecular biologist, I would submit my paper, and I did, and I have. I would submit my paper to a journal that dealt with molecular biology. And there would be scientists who would read it and say, yep, he's got this right, his procedure's good, let's publish it. And it would be published, and then if I goofed up, people would be publishing articles that say, that idiot Vic Marshall, he didn't know what he was doing, bad hypothesis, he didn't collect the data right, and so on. There's a checks and balances in science. So we keep giving this publication and we keep following through with people who have published. And after things have been published again and again and over, we consider things to be factual. We also use the word theory, and that's a confusing thing to a lot of people. And I want to talk a little bit about that. I have a theory on why Betty Gulliver and Alice and Lynn all wore teal today. Oh, and Anne Green, you kind of got some teal there too. May have been the only thing clean in the closet. I don't know, but I can come up with some wild guess as to why. Maybe they just called each other and said, well, let's all sit in the third row from the back and let's wear teal to confuse Vic. I don't know. But to a scientist, that's called a hypothesis. We call it, as a layperson, a theory. But a scientist would call it a hypothesis. It's just it's a guess. We've kind of watched things and we kind of know, so we're going to use this thing called a theory. So, after things have been studied for a long time, we give them credence by calling them a theory. So we've got the theory of aerodynamics that explains why that 747 jet gets off the ground, why when you throw a curveball it curves, and so on. We have the theory of electricity that Gary tested this morning when he turned on all the lights, and we can test them by turning it on and off. Every time we turn things on and off, we're testing the theory of electricity. It says electrons go through those wires, and if we interrupt them, the appliance, the lights stop. Theory of planetary motion, it said what time the sun's going to come up today, when it's going to set, when the moon's going to rise and set. It's going to tell us about a solar eclipse. It's coming, I think, is it August 23rd? If you go to Hopkinsville, Kentucky, that's where the eclipse is going to be at its greatest magnitude. That's from the theory of planetary motion. The three I'm going to talk more about today are the theory of evolution, the theory of immunizations, and the theory of global warming. Been a lot of attacks on science, and I want to use these three as examples of them. Fake science, fake news, not strong scientific agreement, alternative facts, it's just a theory. How many times have you heard that in your lifetime? Those scientists, it's just a theory. Well, to a scientist, a theory is fact. Data don't support conclusions, many scientists disagree, and so on. Evolution, the thing that first brought Gretchen and I to this church, and our children, was a theory called scientific creationism that the Columbia School Board of Education adopted as science for the Columbia schools. Well, a bunch of us went and testified against it, including Reverend Ruth Smith, and that's where I got acquainted with this UU church. It was just a couple miles from our house. There's tons of evidence for evolution. I actually gave a talk on evolution many years ago at this church. The fossil record, the geographic distribution where animals that are kind of alike are found close together. Our anatomies are comparable, our embryology is comparable. With selective breeding, the way we breed dogs and cats and crops and everything else, we produce evolutionary type changes. This last one, similarities of molecular biology and DNA, boy, that's just adding tons of evidence to the other evidence that we've had before, and it all fits together to explain things. Immunizations is when we introduced either a dead or a very weakened amount of organic material into our body, and we produce proteins to bring about its destruction and removal. In 1998, a British physician by the name of Dr. Andrew Wakefield published a research paper in the Lancet Medical Journal, and he linked autism spectral disorders to the MMR vaccine. It was later discovered that he had multiple conflicts of interest. He'd manipulated the data. Fake science. The Lancet ultimately fully retracted the article, and he was banned from the practice of medicine in the UK. He can't publish in any journals. And the scientific consensus is that the MMR vaccine, folks, this has been tested over and over and over again, doesn't cause autism. It's not related to it. There are some pesticides that scientists are studying and working with. Pesticides make a lot more sense than a vaccination. And yet, February 16th, 2017, a presidential order was established to try to find the link between the MMR vaccination and autism. Global warming, that's the one I'm supposed to do my talking about. It's a Chinese plot, it costs American jobs, scientists don't agree on it. There's email bullying, so we're not going to accept this, falsified data. Boy, the last one is way off base. Global warming is an extremely serious issue. It's disrupting everything. Everything. Global warming, we all kind of experience it in the wintertime when our car is parked outside, the windows are all up, and the car gets warm inside. That's what global warming is. It's a different cause. Now, what happens when the sunlight hits the Earth is it warms the surface, and some of that heat energy is re-radiated out into space. What the theory of global warming says is that we have these greenhouse gases, mostly carbon dioxide, but also methane, and methane in increasing amounts. When that outgoing heat starts re-radiating back, it comes to those greenhouse gases, they get warm, and they re-radiate the heat back to the surface of the Earth. That's all it is. Some new idea, some new hypothesis, theory, whatever, that what it is. Well, scientists all call it a theory because there's so much data to support it. This is a graph that shows temperature changes and carbon dioxide concentration. I'm not sure how well you can see it back in the back there, but there's a red line and then there's a yellow line, and what that shows is carbon dioxide concentrations in the atmosphere. Now, you probably can't see it, but around 1958, the red line changes to a yellow line, and it's because in 1958 we started actually measuring the carbon dioxide concentration in the atmosphere. The red line, did I say that backwards? The yellow line is what's actually measured, and the red line comes from bubbles of gas, of atmospheric gases that have been trapped in glaciers that are hundreds of thousands of years old. And we can take those out under very controlled conditions and analyze them and say, well, there's this much carbon dioxide, this much methane, this much nitrogen, this much oxygen, and so on. So we've got a real good record. The blue line that zigzags up and down, those are temperature changes. Well, notice how the two graphs kind of roughly parallel one another, especially as we get into modern times since 1958, where we're actually measuring things. Now, the scary thing is how the curvature of the line is starting to sweep up. Scientists use graphs to explain things because it's a good way to visually get things down and get a grasp of a whole bunch of numbers that would be meaningless otherwise. And typically in graphs, and the ones I've looked at over my professional career, we'd have a graph where the line went up a certain way and say, this is the most likely scenario. We'd have a graph that was at a different angle and we'd say, this is a best case scenario, and a graph at a different angle and we'd say, this is the worst case scenario. Well, for years, as we measured carbon dioxide and concentration and temperature, it didn't hit the most likely scenario, it was below it. It was best case scenario. In recent years, it's doing this. It's gone into what's called a geometric progression. Now, you can see it better if you look at a longer geologic time frame. And again, this comes from Ice Age records, from studying annual rings of trees, all kinds of data that we can look at and find in different fields of science, and they all dovetail together. They all tell the same story. Temperature was relatively constant. Carbon dioxide concentration was relatively constant. Volcanoes erupted, sunspots occurred, solar storms, all kinds of things, but there were checks and balances. Things stayed relatively constant. Boy, look what it's doing now. Carbon dioxide concentration was 280 parts per million. That doesn't sound like much, does it? 280 parts per million in our atmosphere. And the temperature stayed the same. We started kicking it up, and I don't know if you can see it or not, but this graph goes up to about 2010, and at that point the carbon dioxide concentration was 370 parts per million. But notice the graph. It's sweeping up more and more rapidly. It's kind of like being in an automobile where you tromp on the accelerator and you keep going faster and faster and faster and faster. Scientists don't know what's going to happen. The politicians are correct on that. We don't know, we can't predict. When you're in a car that's going faster and faster and faster, you don't know what's going to happen. It's tough to predict. Is it going to be good or bad? Probably not good, is it? That's the scary thing. We've lost our checks and balances. Now, who started this whole thing on global warming? Al Gore with his 2006 film, An Inconvenient Truth, or Al Gore when he held congressional hearings on it 30 years before that. This is not new stuff, folks. Aren't birthdays great? This guy is the guy who turned me on to biology. I was a chemistry physics major, and Dr. Bill Stevenson taught me biology in the spring of 1964. He talked about global warming way back then. 1964. The temperatures are warming, melting polar ice caps, more extreme weather events, crop failures and famine, more species extinction. That's what was projected. At that point, it was probably a hypothesis, kind of a wild, yeah, I think this is going to be what's going to happen. And boy, how many of those things are happening today? This guy is known, and he's very famous for a lot of things. To scientists, it's the bottom one. He authorized the establishment of the International Geophysical Year, 1957 and 58. That's when scientists from all over the world came together and started pooling their resources so that we didn't have data in Iceland, didn't have data in South Africa, China, Korea, Japan, the United States. They were kind of all over the place. After that time, remember the numbers changed on the graph from estimates of what was in the ice to actual numbers? This is when we started measuring. And this is when we started realizing that we were in a geometric progression. We were spinning faster and faster out of control. This guy, look at the date. 100 years ago, let's say today, 100 years ago, Alexander Graham Bell, what's he known for? He's a telephone guy. He invented a telephone. He's the one who first coined the term greenhouse effect. Look what he suggested we use 100 years ago. This guy was the first president of the Nobel Prize Institute. He's the one who developed our gas laws. You know, if you double the pressure of a gas, you half the volume. When you do that, there's a certain amount of temperature released. All those things about gas laws we still use exactly today. They have not been changed. 1896. He wasn't the first to come up with this idea of global warming. This dude was the first. How do you like all that facial hair? John Tyndall, 1859. Not new science. Here's what's happening today. Now, periodically I see politicians on late night TV, or I read their press releases. One I heard this winter was, well, actually it's getting colder in the Antarctic. And if you look at the blue areas, yep, there are some areas with all of the buoys and things we have out measuring temperatures. There are some areas in Antarctic, North Atlantic, North Pacific where it is actually cooler. But what's the big picture here? They're just slightly cooler. I'm not sure how well you can see the graph. White is the same. The more red it is, the hotter it is. The more blue it is, the cooler it is. Well, there's some slightly blue areas, but boy, look at the North Pole. They set a record this winter, February 16th, 70 degrees at the North Pole. Don't know where Santa went, but pretty warm for the North Pole. Glaciers and polar ice are melting faster every year. Storms are more erratic and extreme. Extreme rain, extreme drought, extreme winds, massive famines around the world. Syria. Now, Syria doesn't make the news much for the massive famine that they've had there, but they make the news a lot for some other stuff that's happening there. The same for Central Africa, the Horn of Africa. Those areas are in massive droughts, and people are immigrating out of them as fast as they can make it. And they're destabilizing Europe and the world. Ocean is becoming more acidic because of carbon dioxide. You know, I talked about the graphs a little bit ago, and I said the most likely, least likely, or the best case scenario and worst case scenario. Well, the best case scenario, what we didn't realize was how much carbon dioxide the oceans could uptake. And they were taking it up and taking it up, but the oceans are warmer now. And so the oceans are starting to release that carbon dioxide, and that's another thing that's causing this curve to start to sweep upward, out of control. Less checks and balances. It's kind of like, have you ever taken a warm Pepsi and a cold Pepsi, or I shouldn't say a brand name, a cold carbonated beverage and a warm carbonated beverage? You unscrew the warm one and almost no matter what, it's all over the place. But the cold one you can unscrew without a problem. It's because carbon dioxide there's less soluble that will dissolve in warm water than in cold water. So as long as the oceans were cold, they could just keep uptaking that carbon dioxide. But now they're warmer, and so they're starting to release it, and in addition, we're releasing carbon dioxide. I don't know if you've noticed, but on the news this morning, There are 18 wildfires in Arizona and Utah that are burning out of control. We're in the early stages of the sixth major extinction of life on Earth. The permafrost, permanently frozen tundra, is melting. And as it melts, it's releasing vast quantities of methane. Now, carbon dioxide has this much global warming impact. Methane has 50 times that impact because it's a bigger molecule. It re-radiates energy differently. If we go back and study Arrhenius, Svante Arrhenius, he could explain why those different molecular sizes radiate things better. That's I can't remember if this one's Canada and that's Siberia or vice versa, but same thing is happening in Canada and in Siberia. This is Alaska. This is Canada. In the wintertime, if you poke a hole in the ice in this permafrost area, you know, the muck that's down underneath the permafrost, as it decomposes, it releases carbon dioxide and methane. Well, there's a game that kids play. They poke a hole in the ice and put a flame down there, and they get this torch. The gases burn as it comes shooting up out of the ice. There was a Shell educational video I was going to show you, but it takes about 3 minutes. In 1990, Shell Oil Company produced a video that said, global warming is a terrible problem and we've got to do something about it. 1990 is when they produced it. It was an educational video that they used in Europe. It's since been discontinued, but somebody had a copy and they shared it with the Guardian newspaper. If any of you want to see it, come on up after church and I'll be glad to share it with you. Scott Pruitt, the current chief of the Environmental Protection Agency, stated tremendous disagreement about the impact of carbon dioxide and other greenhouse gases. So no, I would not agree that CO2 is a primary contributor. He said this March 9th, just before I was supposed to give my talk that got interrupted due to the weather. He got us all this week. He's mostly replaced the science advisors of the EPA, the guy that read the articles, read the publications, read the study and say, yep, this is good science. Oh, this is fake news. We've got to get rid of it. Most of those science guys have been replaced by lobbyists this past week. But he says there's tremendous disagreement. This is a pie graph, another kind of a chart kind of thing that scientists use. I'll read it because I'm not sure if you can see it in the back. From November 2012 through December 2013, this guy, I think it was a master's thesis, I can't remember now. I wrote this back in January. Some of these things are a little bit foggy, but anyway, he studied he read 2,258 science journals that had been written by a total of 9,136 authors. Out of those 2,258 peer-reviewed science articles, one article, one author. Out of the 9,136, one author said, well, I'm not so sure. I don't think global warming is man-made. Can you imagine getting that type of consensus? Think we could get that kind of consensus in our church on anything? Scientists are just like us. They're tough to get to agree, but they all agree on global warming. All of them who study the data. Well, the consensus says we shouldn't exceed 400 parts per million of carbon dioxide and a 2 degree or 3.6 Fahrenheit degree temperature increase. In the year 2000, carbon dioxide was at 350 parts per million. Last year in September, we hit 400 parts per million. Whoa. When I took biology I'm not going to say when, a while ago, 2 or 3 years ago, Bill Stevenson said 400 parts per million is the tipping point. Once we get past that, we don't know what's going to happen, but it's not going to be good. 400 parts per million, that's what the scientist, he was a biologist, but that's what the physicist, my physics teacher also talked about global warming in physics class when we were doing the gas laws. We're now at 408 parts per million. We are not slowing down, folks. We're on that curve, that geometric progression that has less and less checks and balances. But I've got on my rosy colored glasses here, my UV protection. Anyway, we pulled out of the Paris Accord, but over 60 Mayors have affirmed commitment to it. The state of California and several other states have affirmed they are going to follow through and they're going to do better. They're going to do more. The CEOs of most major United States corporations, I could have filled the whole page with small print. I just put a few: Google, Apple, GE, Goldman Sachs. Goldman Sachs? They've affirmed their commitment. They're going to loan money to projects that reduce global warming. In 2008, going back a little bit, utility companies had petitioned the EPA to relax the standards because we were coming up short on energy. Utilities could not produce enough energy to satisfy the electric demand of business and industry and personal homeowners. Instead, the government at that time enacted conservation measures and encouraged the installation of less expensive methane-fired generating plants. Methane produces a lot less CO2. As a result, since that time, 248 coal-fired plants, the worst polluters, have been closed. Natural gas plants are more cost-effective, they produce less carbon dioxide, and we've now reached a point where solar cells and wind turbines cost the same as to build a natural gas-fired plant. They cost the same. And they're cheaper than coal. I don't care what happens politically, we're not going back to coal. Coal-fired plants are going to keep dropping off the map because it's more expensive. They don't care about the environment. I shouldn't say that quite that way, but the environment is not the first concern. The first concern is the bottom line, and the bottom line is that it's cheaper to get out of coal and get into natural gas. And oh, by the way, if we do solar and wind, the fuel is free. Still get the capital outlay cost, still have the maintenance and all those costs. There are now more jobs in solar and in wind than there are in coal and in petroleum. Why aren't we encouraging that? That's getting into the politics, and that's not my talk here today. People around the world share the goal. We all want a place to live. We want to reduce greenhouse gas emissions. China was building 16 brand new, super big coal-fired plants. They've all been canceled. These cities are now powered by 100% renewable electricity. Aspen, Burlington, Greensboro. These cities are committed by 2017, Palo Alto, Georgetown, Texas. There were several days this spring. Remember when we had the big winds here? The wind turbines in Texas were generating so much more electricity than the Texans need, they were selling their extra electricity on the grid to other state utility companies. These cities are committed to 100% renewable energy by 2020. Look at the top one. And look at the bottom one. Conservative Grand Rapids, by 2025, they want to have all their city operations run by renewable energy. Science predicts, tests over and over. We've been predicting and verifying burning fossil fuels has caused global warming. There is no other hypothesis. Sunspots, volcanic activity, lack of volcanic activity, airplanes, none of those give us a graph where the two things overlay and match up. The only one that does is gases. Reduce, reuse, recycle. That's kind of the environmentalist maxim, and it has been for years. Share your concerns with friends, talk to your lawmakers, utility companies. Gretchen and I have switched from Consumers Energy for electricity. We're now buying our electricity from Acadia Power. It's a wind farm out in Kansas, and they put the power in the grid, and we get the power out of the grid. Electricity comes from all kinds of plants. It doesn't just come, all these networks hooked together. So we're paying the same amount for electricity from Acadia Power as we're paying for Consumers Energy. But hopefully it'll sustain things, and once I get a couple bills, I'm going into Consumers Energy and say, you know, I'd rather buy energy from you guys. When you're going to put up some windmills? When you're going to install some solar cells? They like that bottom line, folks. Everybody does. Vote for those who are committed to the earth. Get involved with politics at any level. One of the groups that I belong to had a political action group, had 900 and some people request help running for office in 2016. Since that time, they've had requests from over 10,000 people to gain help in running for political office. What can you personally do to save energy? Back where we started from, our Earth is just absolutely gorgeous. The more I study and learn about it, the more I love it. Quality of life on Earth is dependent on how we treat the rest of life on Earth. We have a moral responsibility to look after the rest of the world. The future is now in our hands. What are we going to do with it? Questions? Comments? Marge?
That curve,
Yes.
it reminds me of the population curve.
It's the same idea.
Same curve, exponential growth.
Yep.
So presumably, can we say there might be some connection?
I'm sure there is a connection. More people mean more cars mean more products, more petroleum burned. So yes, I'm sure there is a connection. A geometric progression is something where it keeps growing faster and faster. Have you ever heard that old adage about somebody working a day for a penny, and the second day they'll double that, and the third day they'll double the second day, and the fourth day? Well, some of you may not realize it, but many years ago, Jane Volk was our neighbor. And after Bob had died, some of you didn't know Bob, but some of you have met Bob, her husband. After Bob died, she was worried about mowing the grass. So I said, well, Jane, I'll mow the grass for you. I'll mow it next week for a penny, and the week after that for 2 cents, week after that for 4 cents. We figured I'd have to mow the grass about 10 times that first year. The last time I'd mow the grass, she'd have to pay me $10.24. And then the second year, again, we figured about 10 mows the second year. The last time I'd cut the grass, just the last time, she'd have to pay me $10,024. And then the third year, the last payment would be $10,891,091, I think it was $311. So Jane moved away from Clark Lake. That's a geometric progression, that kind of a curve. It gets, the longer it goes on, and that's why it's so critical that we start doing things now. The longer any geometric progression goes, the more difficult it is to change it. Now, there's a lot of good things going on. There's a Chinese firm that's trying to figure out how to make concrete by extracting carbon dioxide from the atmosphere. There's another company that's trying to trap methane and use that methane to make petroleum products, to make plastics instead of using petroleum products. So there's a lot of good things going on. I could talk on and on and on, but coffee hour's coming, isn't it? Anything else? I'll be up here if anybody wants to come up and see that Shell Oil educational video afterwards. Thank you.